Thank you very much. For the beginning, before I start, I just have to ask you to excuse me something. I will talk about my personal experience, and if you think that there is too much me in this talk, then don't take it too seriously. It's just my personal experience. It's not because I love myself. It's quite opposite, but because I just want to show you my experience through my life. This is the map of the country that I was born in. It's named Yugoslavia. When I was young, I was 13 years old. I drew this map on the piece of wood, hammered some nails in the wood, drew this map, hammered the nails in the positions where the biggest towns, cities in Yugoslavia are, and made the list of those cities on the right side. As you can see, I nailed I hammered the nail near each name of the town. Connected those nails at the back of that board, and just made the simple circuit. I was 13 years old and I didn't know anything about electronics, but I knew how to close the electric circuit and to light up the lamp, which is in the middle on the top, as you can see, in series with the battery. So, if you take this left probe and connect it to one nail, on the position of the city, and if you know where is that city, you can connect another probe with that city. If you are right, then a lamp will light up. If you're not, it will not. That's all. I didn't need too much knowledge for this. I was 13 years old and I sent my project to a magazine which was named Tehničke novine. It's technical papers. And I was very proud when I saw it in that magazine, and I even got some fee for that. And I was very young, but everything started good. Everything started very nice. So it encouraged me to continue. The one thing that I didn't know about this is that I made my first logic gates. There are 17 cities here. That means that there are 17 AND gates here. That's what I didn't know. I didn't know what are logic circuits, but I built them at the beginning. So I went on. For the beginning, I needed a lot of electronic components. There was no internet then, of course. I had no literature. There was no literature here about those items. But I had to collect somehow the knowledge about all this. I collected some transistors. You see them here. Transistors were very, very expensive at that time. You won't believe they were very expensive. But I went to the junkyard and just picked up some old units and desoldered the old transistors and used them. The same was with the diodes, with the resistors, with capacitors here. And of course, I needed some electronic tubes. So I started my work. I started working, and for the beginning, I was interested in ham radio. I was ham radio operator, and I got my license. I passed all the exams, and I got my call sign here. You see it here. It's YU10PC. and starting building my first radio transmitter. It was nice. I joined the radio club and picked up a lot of knowledge from the people who they were much older than me, collected a lot of my knowledge. But there was something, I thought that it will be my future. I loved the electronic from the beginning. I thought that it will be my future for my whole life, ham radio, but something appeared that spoiled the whole thing. We've got ham radio units which were commercial units. You can buy them. Now compare those beautiful ham radio with my garbage down on the table. It's really not so encouraging. I didn't like it. I didn't like it. The another thing which was not so good for me is that when you had no commercial ham radio units, you can talk on the band with the people who from the whole world, the people who made their ham radio units with their own hands. They had to have knowledge. But to buy this beautiful radio unit, you don't need to have knowledge. You need to have money. And if you have money, then you're not interesting friend for me on the band. I think that similar thing happened with computers. Commercialization destroyed computing, but it happened a few decades later. Well, then I had nothing more to have with ham radio because I was not rich. I couldn't buy this ham radio unit. I was a poor guy and I just had to leave it. I was not welcome anymore. So I started experimenting with my own logic circuits. I even didn't know that they are called logic circuits. You see, I didn't have enough knowledge about electronics, about the theory of electronic circuits, but the great advantage of dealing with digital circuits is that you really don't need too much knowledge of electronics. You just have to be interested and to love this area, and I was interested and I loved it very much. I said that I had no documentation, no literature about this, no internet at that time, of course, and I just wanted to make the circuit which can memorize one bit of information. I didn't know that it already exists, but I invented my first flip-flop. I really invented the first flip-flop. It was my invention. The only thing is that I didn't draw it like on the left side, which is usual now. I just draw it like the right one, but which is exactly the same, but in some other arrangement of components. And I start making my own digital devices, and it was the real thing for me. I'm still doing it. my first project was digital clock with Nixie tubes. Have you ever seen those Nixie tubes working? They're really nice. They glow in the darkness. You can't imagine in that time how thrilled I was to see it work, but it worked really. This is not that one. I have not the photography of that digital clock. This one I found on the net, and it was quite similar to my clock. So I can remember it was almost the same like this one, and it worked. But I also heard, I didn't try to understand computer at that times, but I heard that there is something new on the market. It was maybe the first half of 70s. In 73 years I was in the army and I tried to find as much information about microprocessors and computers, but I didn't manage. When I came back from the army, I just couldn't gather enough. I didn't have that wow information just to understand how computer works. But I was lucky enough to get some book which opened my eyes at that moment. It's this book. This is that book. I will keep it for my whole life, and I love it very much. When I saw this book, everything was quite clear to me. How microprocessor works, you see, it does not look too much attractive. Even its headline, Z80 Assembly Language Programming Manual. Does not sound too good. But when I saw the first instruction, when I saw the description of the first instruction, it is, you have to load one register from another register. Everything became clear to me. You see, the first two binary digits, this is 8-bit processor and it has 8 bits, as you can see. The first digit I saw, 01 means load. Then I know. It goes to the instruction decoder, first 2 bits. The next 2 bits are destination register, then those 3 bits go to the destination register decoder, which issues the write enable signal to those 8 bits of the selected register. And the next 3 bits are source register. They just generate through the decoder again, generate the output enable signal from source register. Everything was clear to me, everything. And so when I opened the next page, everything became clear to me and I couldn't sleep that night at all. I was so thrilled that I couldn't sleep that night. And that was the day when I fell in love with microprocessors, especially in assembly language. And now I don't use any language anymore. I do all my programs in assembly language. Maybe that's strange for you. I've heard a lot of things about a lot of opinions of people who tell me that I have to change something to use the higher languages, but I never managed it. I said higher language is like when you make sculpture out of Lego cubes. But I want to take the hammer and to take the stone and to make my own sculpture of the stone, not of Lego cubes. I want to do it myself. I want to have my freedom. And that freedom assembler is the only language that can give me that freedom. The next step was to have some microprocessors, some EPROMs, and some glue circuits, some logic circuits, and I did it. I ordered 2 microprocessors, 2 Z80 microprocessors from USA. They costed $20 each, and I was waiting 2 months to get them. They arrived finally, and I got 4 EPROMs from my godfather. He gave me 4 EPROMs, 2708. They are 1 kilobyte EPROMs. But I had to make my own programmer for the beginning. I also don't have the photo of that programmer, but it looked something like this. It was, of course, it was not a processor-driven programmer. It was hardware type. They asked me, why didn't you make it with the processor? How can I make it when I need the program? When I have to burn the EEPROM for that programmer, it's like the key in the box. When the box is locked and you have the key, but it's in the box. The same is here. I had to make it to realize it in hardware completely, and I did it. Those displays, 7-segment displays that you see, maybe you think that those are LED displays, but they are not. There were no LED displays at that time. Those are some displays which were called Minitron displays. They had some kind of filament inside, like the bulb. But of course weaker, as you have to look at them. But they worked fine. They worked fine. I had the 3 rotary switches. You see them down, which I used to enter the octal code for byte by byte. Okay, and when I insert the EEPROM in the socket at the right side, I just had to keep the prog key for about 2 minutes. Then I said, well, why I just put the key here? Why didn't I put the switch? I had to hold my finger for 2 minutes. But then I saw that this key had a hole on the top. And I have one very heavy metal marble, which I use for programming. And I put my marble on that. It was very, very wise and saved me a lot of time and energy. So you may ask yourself, I didn't have the computer at that time. You may ask yourself, how could I assemble those programs? I wrote down the mnemonic code, and of course I just transcribed it to binary language by hand on the paper, pen on the paper. And so 100 program lines which are assembled just by hand, not by computer. I thought it was not hard for me. Maybe you think that it was too hard, but when you don't know that there is a better way, then it's not hard for you. Then, then you just do it. Thank you. So I had to make programmer work. So for the beginning, it burned 2 EEPROMs, not burned regularly, but smashed them. So I smashed 2 EEPROMs, but I had 2 EEPROMs for my work, and it was good. I made my first project, so I could program 1 EEPROM while another one was erased. I had the lamp for room sun tanning. I don't know, do you understand? It's the lamp with ultraviolet light for sun tanning, and I used it to erase EEPROMs, and it was okay. So I had 2 EEPROMs. I can burn one and erase another one, so the process of debugging, software debugging was going well. It was going well. But all by hand. And my first project was the Game of Life. You know, Conway's Game of Life. It's the brilliant, it's the best algorithm that I ever found. It's the beautiful game. I will just tell you in a few words. It's the kind of cellular automata machine. You have the array two-dimensional array of cells. Each cell can be on or off, or live or dead, or alive or dead, I mean. And microprocessor has to calculate for each new generation, it has to calculate, it has to count the live neighbors. Each one has 8 neighbors, and it just has to count the number of neighbors which are alive at that moment. So if the tested cell has 1 or less, which means 1 or no live neighbors, it dies in next generation. If it has 2 alive neighbors, there will be no change. If it was alive, it will stay alive. If it's dead, then it will stay dead. If it has 3 alive neighbors, it will be born in another generation. It will be alive in next generation. And if it has 4 or more than 4, it dies. So it sounds very, very simple, but those 4 very simple rules create very, very interesting and very complex behavior of the whole field. This is one example. You can see that at the beginning, when you start with chaos, with total chaos, you can see that in the beginning, the cells begin to group. You see it here? Here. They make some group, so they support each other in living. But this is just the beginning. After some time, this grouping and this organization becomes more and more complex and interesting. This is one example here. On the top, you can see one type of organism which is called gun. It contains 2 shuttles which go left and right and which create gliders. Those 5 gliders or 4 gliders are created, and it periodically creates new and new gliders. Those gliders just walk in the space, just like this, and they walk through the space, through the field of that matrix, and here, down there, is the special organism. I like it very much. It's eater. It just eats those gliders and remains unchanged all time. And that's what's fascinating. There are even more complex shapes. See this one. The right one. Here. It is called puffer train or breeder. It moves from left to right, eternally moves from left to right, and after some times it just acts like a glider. It's a very big glider, but it leaves some debris after him, which is actually a series of guns. And those guns just fire new gliders here. Those are guns, and they fire gliders on the top. And this is the shape which grows unlimitedly. It grows forever. It's very interesting. So of course, I didn't have enough material to buy such the big field, such the big array, but I could afford the small 16 by 16 array of LEDs. First, I started building some bigger life, but I didn't have enough material. Those LEDs were expensive, and I was lucky enough to get a lot of smaller LEDs, so I made the new one. This is my In fact, this is second project. As the first one I have not, I don't have anymore. But this is my second project, which was made, well, I think maybe nearly 40 years ago, maybe 37 years ago. This is it, and it still works. You can see it's a small matrix, small field, 16 by 16. And I never had any problem. I never repaired it for 37 years. It still works, and it still works fine. Thank you. Thank you. And I made a lot of new projects with the same game of life, even much more bigger than this, with a much better LEDs, which are lighter and higher efficiency. But this one is special for me. It's very special. Before I made it, I was so fascinated by that algorithm which was created by John Conway. I was so fascinated that when I didn't have the microprocessor and didn't make this project, I draw my generations on the paper. And then just put it like the pictures on my wall. And I couldn't believe that some clever organisms can be created just by such the simple rules. And I'm still fascinated about it. Well, then the time had come for me to have my first computer. It was TRS-80. This is my first computer, but the sad part of the story is that our government in Yugoslavia at that time, those are late 70s, just didn't want us to have computers. They were forbidden. Well, not just forbidden directly, but some way you couldn't import anything that was more expensive than $500. But you couldn't buy the computer for $500 at that time. So I had to, I bought this computer in USA at that time, and I had to ask my friends to buy it for me. I sent them money, of course, to buy it for me, and to take the screwdriver and scissors and cut some cable inside and send me into separated packets. And they did so. They just didn't understand why should they cut some wires of some new and operational unit, but they did so, and I got it successfully, and I had my first computer. Of course, it wasn't enough for me. I didn't just want to see it working. I must see how it works. And I made, for the beginning, I had no disassembler, but I made my own disassembler, of course. This microcomputer works with Z80. A processor, the same one which I used for life, so I was familiar with its assembly language, and I made my own disassembler and started to disassemble its code. And those are two of thousands and thousands pages which I printed out, because I also bought the Epson impact printer and printed the code and analyzed it. You see, a lot of time, those were kilograms and kilograms of paper. Those are just two papers. I maybe have now maybe about 50 papers, not more, but they are all the same. So you see that I just I just made some modifications. Here I have some suggestions about why do they do it in this way. They are not efficient enough. I just made my modifications, which I'm sure were much better than their code, and so on. So, my next step was to make my own computer, which I did, but I was interested in graphical working station. I was very much interested in graphic. You see, this my TRS-80 computer, it has very, very low resolution graphic. It had 64 by 128 dots. Can you imagine that? It's the block graphics. 64 by 96 by, 96 by 128, yes. It's a very low resolution. You cannot draw anything with those graphics. And I had to make my own graphic unit, and I make my graphical station. I don't have the photo of that graphical station, and I don't have that, of course, until now, because I always needed new projects. I never have had enough material, and I had to destroy the previous project to build the new one. So the only information about this, my graphical station, was this is from some TV, it was not show, I don't know how to call it. We talked about computers on TV, and just unintentionally, in one moment, someone shot my graphical station. You see here, this is the blue unit on the left. And it's the only thing that I have about it now. This video is on the YouTube. I found it on YouTube, and I was delighted to see my graphical station here. And of course, I took this shot and just brought it here to show you how it looked. It was maybe this big, like the shoe box. And it had the resolution, if I am right, it had a resolution 520 by 800 pixels. It was very high resolution. It was monochromatic, but with 8 levels, 8 levels of black and white. What did I do next? I had to make my first computer animation. The year was 79. I studied film editing at high school, and I was interested in movies, and I just had to make my first computer animation. There were no computer animation software. There was no software for computer animation at that time. So how could I do that? I made my own software in BASIC, in programming language BASIC, because it had to do a lot of mathematics. I couldn't do it in assembler, so I did it in BASIC. I took one Bolex movie camera, 16 millimeter film. Bolex camera because I borrowed one, because it has a single frame mode. It has just frame by frame mode. Then I added some solenoid which could shoot one frame and which was connected to my computer. So my computer could draw one frame on the monitor and shoot the camera which was directed to it, which was looking at that monitor. Another thing that I had to do, because I didn't have the dark room, to make one very large wooden box to cover all that and to let it work. It needed a few minutes it was extremely slow, of course. It needed a few minutes to make one frame in wireframe mode. I made two shots, maybe 6 or 7 seconds each of them. They are here. I still have them. And I showed it to my professor, which was fascinated. He saw the computer animation for the first time in his life, and he was really fascinated. Then he invited all other professors to see that wonder, the wonder of the world, computer animation. One of those 2 shots I digitalized on my flatbed scanner, but it's not quite stable. You shall see it, but maybe not just in perfect. It was shake a little, but it was not the problem with creating computer animation, but with scanning it on flatbed scanner and assembling it in Photoshop. That's it. That's the whole shot. Thank you. I'm trying to start it again, but oh, I see where's the problem. Here it is. You see, even the camera is moving here. Well, so much about that. I made several computers for my personal satisfaction, and when I was on my vacation, I was at the sea, and I never liked vacations. I never liked the situations in which I cannot work something. But I was freshly married, and I had to go somewhere with my wife, and I went to the sea. But I didn't know what to do, to go to the beach, to lay there on the sun, to bath. So I went to the hotel shop, bought a notebook and bought some pencils and started to work on some new computer concept. The problem with computers at that time is that you didn't have some dedicated chips which could generate. The biggest problem for computers at that time is generating a video signal. You had to spend more than 50 chips, which means that computers had to be complication and somehow too risky for something to make do-it-yourself project with such a complication computer. I tried to make it as simple as possible, and I think that I made it with the Z80 processor, which is the only one that I had at the time. I used the refresh register in that processor in some special way which could help me to generate the most critical part of the problem for video signal generating. And I made it, and I did it. I was hardly waiting to come back home from the vacation and to try it, and it really worked. It really worked. It was year 73. It was late August 73, I remember. I came home, and in the few days I had a new computer which was very, very, very simple, easy to assemble, and which was easy to make it work. I thought that it will be a good idea to publish it somewhere and to offer it as do-it-yourself project for the readers. Somehow I got the information that somebody somewhere is preparing the new magazine which will be dedicated specifically to the computers. At last I found who it was. It was my friend Dejan Ristanovic. He was just preparing that first issue of first computer magazine in Yugoslavia, which was named Računari u vašoj kući, which means computers at your home. It was planned for the new 84 year. The year was 83, and it was planned for the January the 1st of 84. So I had a few months more to prepare that computer as much as I can. I met Dejan Ristanovic. He's here. I met him. And he was, of course, he agreed to offer that do-it-yourself project in the first issue, and we somehow made that concept for the software for that computer. The software had to be low cost, which means to occupy a small amount of program code memory. You know, program code space was very expensive at that time. It was very expensive. So to keep the whole project low cost, I had to just to limit it to 4 kilobytes. But you can't imagine what you can put in 4 kilobytes. I took level 1 basic, which was free, which was based on free software at that time. I'm not sure how free it was, but it was based on free software. I took it, but at the beginning it was completely stolen. But then I had to rearrange it to make some improvements, and I made a lot improvements, so it was not the same software like in the beginning. It was almost completely my software to the end. I put a lot of new functions, and I will talk again about one thing later, which I was very proud of. But for the beginning, just let me tell you that we had to work a lot to prepare the documentation for that do-it-yourself project. The guy on the left side with the beard is Jovan Regasek. He was editor of that first issue of that magazine. I'm at the right side. We were making the first prototypes of that computer. Jovan Regasek was the editor of magazine Galaxia, and computers at your home at the beginning were just released as the special issue of Galaxia magazine. So he made the proposal to call the computer Galaxia, and I agreed completely, so it was named Galaxia. This is the schematic for Galaxia. As you can see, it's quite simple. It has a microprocessor, 6 kilobytes of RAM, and 4 kilobytes of ROM program code memory. and one spare socket maybe to extend that program code memory, which was realized later. Those are the instructions how to assemble that computer on the PCB and how to assemble the whole unit. And here we have it. Microcomputer Galaxia, which was released in time, even a few days before that New Year. I will just tell you about one thing in the software. I'll try to explain it. Now, when I make some software for some controllers, I use maybe 5 or 10% of program code space. I don't need more, because program code space is cheap now, is very cheap. But it was very expensive at that time. And I wanted to put as much functions in 4 kilobyte limited code space, and I have to save each byte of code space. And somehow I managed to use not 100% of space, but more than 100. How did I do that? You see the first instruction, I talked to you about this instruction from my book, from this book, which is load instruction. From the other position, I had also a part of program which generated the video signal using this refresh register, and it just had to waste 32 instructions doing nothing. Those were instruction NOP, no operation. But I thought, why would it be no operation? Maybe I can use it somehow in some other way. You see, at the right side, you see that part of the code which generates video signal. You have you see 32 T red letters, which just signifies 32 clock periods. And those clock periods were just no operations. But at some moment, I had to insert some string, some ASCII string, some message which computer had to display, and that was message break. When you see how for message break, you see here, those are ASCII codes for message break. Those are binary ASCII codes for message break. Those are hexadecimal, those are binary. And those are instructions for Z80 microprocessor if you just execute your message break in the processor. And I saw that those were just load commands. You see, 0, 1, I told you that decoder just decodes just like load instructions. But also the ASCII capitals, B, R, E, A, K, also begin with 0, 1. So I used it just to use the same code space as the message and as the executable code. You see, so a computer can treat it as message break and treat it as code, just writing each horizontal line while generating video signal. So I used more than 100%. I never saw that anyone anywhere made the same thing to make more than more than 100% code use. Another thing that I did, I had some more space here. Another thing that I did is just to make some, you see here, those red digits are mainly zeros. I need some constant for a floating point arithmetics. I needed some constant, and I just managed to insert in here in the same video generation routine. So I used 10, 6, this 0, 0 is terminator for this zero message, for this break message, and 4 bytes more. So I used 4 bytes out of nothing. I made them somehow out of nothing. And it worked. I saved 10 bytes. Fine. I can use it for something, then I used it up to the last byte. So the first issue of magazine was released. Before it was released, the editor, Voja Antonic, the author of the first issue, Dejan Ristanovic, and I were sitting when the whole work was done. We were sitting, drinking coffee, and talking about how much people will make that computer, Galaxia. How much people? And Voja Antonic asked me, what do you think, how much? And I said, but if we have 50 people that will make it, I will be satisfied. And then Dejan Ristanovic said, oh no, don't be silly, there will be at least 200 people. And Voja Antonic said, no, there will be at least 500. And I said, oh no, that's too much, 500. But in the first month, we received 7,000 letters of people. It's too much, really. It was 7,000 letters just in first month after that magazine, and that magazine was printed again and again and again 3 times, up to 100,000 magazines. Well, it was very successful. After that, we had somehow to how to say that, to educate people what are computers at all. Everybody was interested in computers at that time, and almost nobody knew what are computers. And Dejan and I were invited to TV shows, to radio, just to talk about computers. And each time Dejan got the same question, what the computer can do? And I've got always the same question, how did I get the idea to make the computer Galaxia? And we had maybe 50 times to answer the same questions. But luckily, there were some more creative authors of radio and TV shows. One of them is Mr. Zoran Modli, which is here with us today, sitting in the last row. He made one very big move. I didn't agree with him for the first time. He said, let's have some programs for your computer Galaxia at the radio. We will broadcast them, this program, which is just the very unpleasant noise. You see, programs at that time were not held on hard disks or on floppy disks, but on cassettes, on audio tapes. And you can hear them. It was in audio range, and you could also just emit them through your broadcast radio station. Zoran said, let's emit that. And I said, oh, no, I think I don't like that idea. It's unpleasant. You will make people run away from your show. And he said, no, let's just do it. And we did it for weeks, for months, for years. And we had very fine replies about that. I think that he was at that time some kind of wireless was born. You see, we had wireless. Yes, in middle 80s we had wireless, just through FM radio. Why not? It was wireless. It was just transmitting the digital data through the radio. It was wireless, really, and the author of that idea was Zoran Madli. He is here with us. I said that those were mid-80s and maybe late 80s, but the 90s were not so good, so lucky. That's the sad part of the story. 90s came. We had a lot of problems. We had civil war, we had hyperinflation, we had a lot of problems. What shall we do about it? That was a really bad time, for me especially. I said it was war. We were all very poor. It was hard to live at that time. Some guys were gave me some very bad opinions on my computer, on Galaxia, because it was obsolete at that time. Already we had much better, much faster, much more powerful computers. Of course, that Galaxia was forgotten. And anybody who talked to me about that at that time told me that Galaxia is bad computer. It's funny. Why did you make so bad computer? But how can I tell him that I cannot fight with someone who has very unlimited budget to make the power microprocessors, powerful computers, and so on. I just cannot follow him. I was forced to feel ashamed a little. At the middle of 90s, I had a lot of bad experiences about that, but not only about that. Also, at the beginning of 95, first my father died, and 10 days after him, my wife died. Then, at the same year, at the same month, I had to leave my flat. I was informed that I have to leave it and to move somewhere, I don't know where, when my second child was born. It was not yet 2 years old. I had no money. I hadn't anything, you see. And I was ill at that time. I was very sick. I couldn't move for 6 months. I was tightened to bed with no money, with no hope. And I thought that it will finish very bad at that time. I remember it as that year as a very bad year. So after 6 months, I went out of bed, started to just recover somehow. And I made my very good project with microchips, microcontroller, PIC 16F84. Very good project, really. I called it the engineer's assistant, and I sent the details about that project to Microchip, to their application manager. And I described it to him. It was some instrument which contained a logic probe, which contained serial data analyzer, and which contained also the digital single channel analyzer. You see its application here on the photo. And it was one single chip unit. It had only one microcontroller, and it did all that. That microcontroller had only 1 kilobyte of memory, 1 kilobyte. I sent him a mail, and he said that it is impossible to put so much functions in 1 kilobyte. And I said, oh, don't tell that to me. And he asked me if it's really true to make 5 those units, to send them to factory, which they will use at their conferences to demonstrate what can be done with such the small microcontroller and such low power microcontroller to make so many functions. I did it and sent it to them. When they received it, they said that it's a miracle, that they will make the big article in all magazines, that they will just they promised a lot of things to me, and also some fee which I could ask from them. I said that I don't need no money, that I need their development system for their microcontrollers. They said, fine, just do it. I did it, and made its application note AN689. It's still on Microchip's site. Make the whole project description, and just waited for my fee. But when the time had come for them to send me that fee, they said, evidently your country is under embargo and we cannot send you anything. Stop. That was the end of our conversation. They didn't answer my mails anymore. Next year, I got my fee. That's it. That's what I've got from USA. We all got the same thing, and we know what does it mean. So, I've got my development system 8 years after that. 8 years after that, when it was quite obsolete, but, well, okay. I've got it somehow. Things, in some way, things just started to move and to become better and better. People started to see computer Galaxia not just like something which is obsolete, but something which is the part of history, which really is. And I've got the question from Museum of Science and Technique. Can I give them one computer? Of course I can, but I don't have it. In '95, when everything was just going down for me, and when I had to move somewhere, I just took all my prototypes. I had 5 or 6 prototypes. I just took them all and just dropped them in the garbage. I don't have them anymore. But somehow, luckily, I found in my cellar one which was forgotten. I found one and gave them one, and now it is in the museum. You can see, I'm really very honored about that. especially because there is a lot of people who are talking about that computer again, about computer Galaxia again. More and more people contact me and ask me to send them the software, to send them the PCB layout and instructions how to make it. Can you imagine? They now want to make this computer again. There is a lot of simulators of Galaxia for PC computers also. I've seen them. One guy from Slovenia, which name is Tomáš Šolc, he speaked about Galaxia 2 years ago on CCC in Hamburg, CCC conference in Hamburg. He even graduated on analyzing the software and hardware of Galaxia and how it works. My friend Dušan Grujić also made the single chip version of Galaxia. This is Galaxia. Here is it. He gave me one, and it really works fine. You just connect the VGA monitor, keyboard, and 5 volts through USB. It only serves to supply this PCB, and it works really like Galaxia. So that computer started to live again, and I feel better now. I really feel better now. And what am I doing now? I still work my controllers, mostly for casino applications. I specialized for shape recognition, optical number recognition, optical reading, counting, optical recognition of casino dices and so on. That's what I do now, and I make the controllers for all those things. So what shall I do later? I don't know. But at this moment, I'm satisfied again, and I see more and more people which can respect my work. Thank you very much. Thank you. Thank you very much. You are very kind. Thank you very much.
You were speaking about Galaxia, and it was open source hardware, right?
Yes, sure. Do it yourself.
Everyone could make it at home.
Sure, yeah.
Was the software also open source?
Yes, sure.
Okay, so
For the beginning.
yeah,
Yes.
you were the first guy in the history of humankind that made open source hardware and open source software.
Well, I don't think that I'm just the first. Maybe you are right.
Open source hardware started like in 2004, but no, it started in 1984. Oh,
Yes, the problem was with EEPROM programming. You see, not everyone has the EEPROM burner at home. And I had to make the EEPROM programmer which programs 5 EEPROMs at a time. And I made it. So everybody sent EEPROMs. One is for code and one is for character generator. Sent to Računari, to the editor. And editor collected all those EEPROMs in 1 week and sent me hundreds of EEPROMs each week. And I just programmed it and programmed them and packed them again. And we had hundreds and hundreds, maybe thousands of those EEPROMs, which we sent back. So, and it was just for no fee. It was free.
Also, you have done the first file sharing ever.
Maybe, maybe, I don't know. Maybe.
And multicast.
Yes. Later I wrote a lot for magazine PC, and I published a lot of projects. I think maybe more than 50 projects. All of them are free. All of them are open source, open hardware, open software. I made really a lot of projects, and I have no patent until now. No. I want to say that I never patented anything and protected it by law. Everything is free.
Some told me that some parts of software for Galaxia were inspired by ZX81.
I beg your pardon?
That some parts of the Galaxia were inspired by ZX81.
Where? I didn't hear it.
I heard it.
No, I didn't understand you. That some parts were
Influenced or inspired by ZX81 Sinclair computer.
I never had ZX81, and I hear it. It's for the first time that I hear it. I don't think so. I never had ZX81, and I was not inspired by it.
I just heard from someone something like that, and
I don't know.
hear the answer from.
It's for the first time that I hear it. Don't know about it really.
Okay, thank you.
It was actually vice versa. Sinclair was inspired by you.
I don't think so. I don't think so. But he was inspired by earning money, I think, and I was not. I earned nothing.
I think that his computer was even cheaper than Galaxia.
Maybe, I don't know.
Yeah. How did you came to the idea to generate the video signals simply just by using the Z80?
I had too much time on my vacation. I don't know really how, but somehow I saw that the refresh register is very, very simple, that it just increments after each instruction, and if I select the instructions which all are timed properly, then I can make the proper video signal. But it's a little complication, just to give you the whole explanation of that process.
I actually tried Galaxia on some newer TVs, and they sometimes have problem with synchronization. And
Yes,
some of
yes.
them that
It's out of standard, yes, yes, yes. Yes, it's not quite, yes. It's not exactly just, it does not follow exactly the regulations for video signal, but all old TV sets at that time accepted it with no problem. Yeah, so, sure.
Where we can buy Galaxia?
I really don't know. You see, I saw that on some mailing list, I saw that somebody bought computer Galaxia from some gypsy, just on the street down there. And he bought for just, and he said there was only one chip missing. It was 74LS 161 shift registers. And then I said, oh my God, but that is my computer. I remember when once I needed that shift register and put it out of Galaxia, which I dropped later. It's my computer. How can I contact him to buy it again from him? but I didn't manage to contact him. Yes?
Are you going on vacation anytime soon?
I haven't been on vacation since 83.
Would you be so kind to go?
Well, sometimes some things are very hard to reproduce and to
Just try.
okay. Yes, but I'm not sure.
Okay, thank you for your existence.
Well, thank you for your kind words. Yes, please.
Yes, I'm curious about the cellular automaton, the Conway's game of life.
Yes?
How do you generate random numbers? How do you seed the grid with random,
There are a lot of techniques. I use the pseudo number generator, which are standard. This is that's 32 bits pseudo random generator, and the seed for that pseudo random generator was fed by the checksum in RAM, which is mostly random. So I add all numbers in all RAM, which is several kilobytes. And that checksum I use to feed the seed for pseudo-random generator. And then I have the enough random sequence.
Did you, in some time, went to a very low HDL or something like that, designing chips?
I didn't hear.
Did you went to writing very log or HDL to design chips?
No.
Are you considering or planning?
Yes, I am planning, but I didn't do it yet. If that's all, then thank you very much.